Remember yesterday I said that there's two laws that we use when we don't have a right angle triangle, right? So whenever we have an oblique triangle. And the two laws are the sine law and the cosine. So yesterday we looked at the sine law and when can we use it. Today we're going to look at the cosine law and how and when can we use it. So the cosine law can be used when you have two sides and the contained angle. Okay? What I mean by contained, what does the word contained mean? Contained. So it's like kind of in between, right? Contained means like when you contain something, that means you close the door on them, right? You contain them in a certain area, right? So a contained angle means is the angle that is contained between the two sides. So what angle would it be? I'm just gonna write letters here. That's a B, that's a C. What angle would be the contained angle between these two sides? Angle A, right? So anytime you have two sides, you know two sides, and the contained angle, you can use the cosine law to find the third side. Okay? So this is when you're looking for the third side and you have two sides and a contained angle. The other way that you can use the cosine law is when you are given all three sides, so you know all three sides, and you're looking for an angle. You have nothing else to look for, right? Doesn't matter which angle you look for, right? You have three sides and you're looking for an angle.
The first one was two-sided triangles?
Sorry?
The first one, that one?
It's, you know two sides and the angle between them. The contained angle. Okay? So, that's why I always say it's easier to identify if it's cosine law, right? Because cosine law, there's only two options, right? You have to have two sides and a contained angle, or you have to have all three sides. Now, if it's not cosine law, then it's going to be sine law, right? Because this is not a right angle triangle. Okay? Now, let's look at what is cosine. So cosine law, you see, if you look right here, right? There is the cosine law. They give you like three different formulas, which is the same formula as well, different letters, and then they give you they're not here. Okay. And then there is another formula. I can print that and put it on the board, on the wall, I mean, and that would be when you're looking for the angle. Okay, so anyway, I'm gonna write them on your notes. So the first one is going to be, so if I know angle A, and I know side B, and I know side C, and I'm looking for side A. Okay, I'm looking for side A, so the cosine law is going to be like this: A squared equals B squared plus C squared minus 2BC cosine angle A. Okay? You know side B, you know side C, and you know angle A. Yes? You know side B, you know side C, and you know angle A. So you can put them all in the formula and solve for A squared. Then you have to square root to find it. Does it make sense? Okay. Now what if I'm looking for side B? What should I know to look for side B? So I know which sides? A and C, right? I know A and C. And what angle do I need to know? Angle B. B. Right? If I'm looking for side B, I know A and C and angle B because that's between them. Right? Okay, so what would the formula be? A squared plus C squared minus 2AC, because I know A and C, cosine B. Okay? That is if I'm looking for side B, right? So I have this case here. I know side A, and I know side C, and I know angle B, right? And I'm looking for side B.
Your A squared minus C squared, because B from there and
No, it doesn't have to do anything with the Pythagorean theorem. Okay? Well, it kind of is, but it is not. It does use the Pythagorean theorem to start with, but it's a bit different. Okay? All right. Now, what if I'm looking for side C? What should I know? A and B, and then what angle? That's right. So what would the formula be? Minus 2 AB cosine C. Good. Good. Right? So no matter what the letters are, you can make your own formula, right? If it's X, Y, and Z, right? It's the same formula. It's going to be this, but then you're going to change the letters. Now, if I know all three sides, if I know all three sides A, B, C, right? So that means I know this A, this B, this C, I know BC, right? And I'm looking for the angle. So what happens is I'm gonna have to rearrange this, bring them over, and divide to get cosine by itself. Okay? So to get this part right here by itself. If I'm looking for angle A, that's it. Okay? So what happens, the formula becomes like this. Cosine A equals B squared plus C squared minus A squared over 2BC. Okay? Do you want to know how we got to this? Alright. So I'm going to take my original formula, which is this. You don't have to write this if you guys don't want to, because I'm going to rearrange it. I'm going to isolate for cosine. What's the first thing I want to get rid of? So I want to isolate for cosine. What do I want to get rid of? No, remember it's reverse bed mass.
we need to bring the cosine over or
That's right. So you want to bring these over, right? You want to bring the b squared plus c squared over first. Okay? So when I bring them over, it becomes a squared minus b squared minus c squared equals to negative bc cos a. Yeah? Are we okay up to this right now? Now what's happening between negative 2bc and cos a? What kind of operation is happening right here? They're multiplied, right? So if I want to bring the negative 2bc over, what does that become when instead of multiplication? Division, right? So I have to divide by negative 2bc. Yeah? So I have to divide both sides by negative 2bc so I can get rid of this. Right? So I have cosine A left by itself. Do you guys agree with that so far? Good. Now, the only difference between this and this is that in the first equation right here, I didn't have the negative in the bottom. So how do I get rid of the negative? I can simply bring the negative up here. Sorry, that's right, because the negative in the top or the bottom, it doesn't matter, right? And then if I multiply the negative in, it's going to become negative a squared plus b squared plus c squared over 2bc, right? Yes? So does this look like what I wrote right here, but it's rearranged? Does negative a squared plus b squared plus c squared over 2bc look like b squared plus c squared minus a squared over 2bc? Yeah. Okay? Now, this is how you get to it. I'm not going to do that for every single equation. So, are you okay with that? Now, this is going to give you cosine A. If you want to find angle A, what do you do? So when you do your math, right, b squared plus c squared minus a squared divided by 2bc, it's going to give you cosine A. If you want to find angle A, what do you do? Inverse cos, that's right. Can I erase this now? Okay. Can you guys think about the second formula? So if I'm looking for angle B, what would the formula be?
A squared negative b squared plus c squared.
So a squared plus c squared
Negative
minus b squared, yep, over
2ac.
2ac. That's right. So you see that the minus belongs to whatever letter it is that I'm looking for, right? If I'm looking for cosine b, I'm going to subtract b squared. Okay? If I'm looking for cosine a, I'm going to subtract a squared. And then cosine c is going to be
Cosine C equals A squared plus B squared minus
c squared
C squared
over
over
2ab.
2AB.
Yeah. Are we good? Remember that you don't have to memorize these formulas. You can use your formula sheets that you can use. Okay, so you don't need to memorize. All right. Now, how do you put them there is very, very important as well. Okay, so I'm going to teach you, make sure that whatever you're doing in the calculator is correct, because a lot of the mistakes happen when people can't use their calculator. All right, let's look at the first example. Find, so the question for example 1 is asking you to find side B. What do you know?
Two sides of
Sine
angle B.
angle B.
Okay, two sides and the angle B, which is the contained angle, right? You see how you have the two sides, right? And the angle between them, so the contained angle. So I have to use cosine, okay? So cosine law says, if I'm looking for side B, this is side A, this is side C. So tell me what the formula is.
B squared, A squared plus C squared, that is very simple.
Cosine B. Now we're going to plug in the information. So A is 20, so it's going to be 20 squared plus
25 squared.
C is 25 minus 2 times 20 times 25 cosine 48. So, okay, so how do I enter this in the calculator? This is basically what I'm concerned about, because a lot of time this is what happens. People try to do the math and then the math won't be correct. You don't need to put bracket, but you need to either enter it all together in the calculator at once, or you want to enter b squared and find the answer for that. You want to enter 25 squared and find the answer for that. But this right here, you have to enter it all together. Okay, you have to do 2 times 20 times 25 times cosine 48. Okay? Or you enter it all together, if you can do that on the calculator. Okay? So I'm gonna enter it each so you guys see that. So 20 squared is 400. Plus 625. And this is going to be 669.13.
So I thought you were doing it in your head for a second.
Yeah, the first two I did it
Yeah,
in my
no,
head.
the 669, I was like,
No.
that's impressive when I saw your phone.
Do you think I know what cosine 48 is in my head? And I'm looking for a side b squared. So for now, I'm gonna leave it to 4 decimal place. I haven't found my final answer yet. So you see what happened? I did the first one, second one, and then the 2AC cos B. I did them all together. Now, is this my final answer? Is this my side B? No. That's B squared. How can I find B? Square root. Right? So once I square root this, right, then I get 18.9. And this is where my final answer has to be to 1 decimal place with a unit. at this one. What do I know? 3 sides. And what is it asking me to find? Which angle? So since I'm finding angle A, let's name these A, B, C. So what's the formula? Cosine A equals minus A squared over 2AC. Okay? So, what am I going to plug in for B? 38. So 38 squared plus 26 squared minus 30 squared over 2 times 38 times 26. Okay, how do I enter this in the calculator? If you enter it as you see it right here, it's going to be a problem. Because what the calculator does, it goes 30 squared divided, like it doesn't even take these, it calculates this, but it doesn't divide these by this. And then it takes 30 squared divided by 2, and then it multiplies by 38 and 26. So your answer is going to be totally wrong. Okay? So, there's 2 ways that you can do this. Can I have your attention for a second? If you want to enter this whole thing in the calculator, you can do that. You have to make sure that you put brackets around the top and big brackets around the bottom. Okay? So this way the calculator knows that I have to do the math for this, and then whatever math for this is divided by the whole thing of the bottom. Okay? This is how the calculator knows that. Now, if you don't want to enter brackets, you can find the top and then write your answer. Calculate the bottom, write your answer, then you do your division. Okay? So, what you can do is, so you do 38 squared plus 26 squared minus 30 squared. Find the answer for that. And then find the answer for the bottom by doing 2 times 38 times 26. Then what you can do your division by doing 1,220 divided by 1,976, and you're going to get 0.6174, and that is equal to cosine A. Is that my angle A? So what do I have to do to find angle A?
No, square root.
The inverse. So you do cosine inverse, so shift cos of the answer, and I think it's 52 degrees. That's rounded up, yeah. Are we okay with this? Alright. So, I want you to find a couple of questions in the homework and try them. And, you know what? let's read that question and draw a picture for it. Two hikers set out in different directions from a marked tree on the Bruce Trail. The angle formed between their path measures 50 degrees. After 2 hours, one hiker is 6 kilometers from the starting point and the other is 9 kilometers from the starting point. How far apart are the hikers to the nearest tenth of a kilometer? So try to draw something on your paper. Or if you guys want, you can come and try it on the board. So two hikers set out in different directions from a marked tree on the Bruce Trail. The angle formed between their path measures 50 degrees. After 2 hours, one hiker is 6 kilometers from the starting point, and the other is 9 kilometers. How far are the two hikers apart from each other? What do you have? What should I have on my, I know it's a triangle. How many things I have on that triangle?
You have angle A, and then like you have side B and side C. You're
Okay,
looking for side
so I'm looking, I have three objects, right? Or three things. I have the tree, and I have the two hikers, right? Where are the two hikers starting from? So this is my tree. Where are the two hikers starting
From
from?
the marked tree.
From the tree, right? And then they're going in two different directions, right? So that means they're walking in two different directions.
That angle's 50.
That angle between them is 50. The first hiker is 6 kilometers from the starting point. So let's say this is hiker 1.
The other one's not.
And this is hiker 2. And then the question is asking me for what?
How far are they from each other?
So what am I looking at?
For
This is
the
the
side
two
view.
hikers and
For the side, right? So I'm looking for this side, right? So name the triangle whatever you want to name it, however you want to name it, and solve for it.